In the previous videos, we have covered uniform distribution, binomial, and geometric. Now, in this video, our focus is on negative binomial and hypergeometric. So let's first start with negative binomial. And we are going to cover both type 1 and type 2. First, we'll look at type 1. Notation is x follows negative binomial k comma p, where x is the number of trials on which kth success occurs, and k is the kth success, p is the probability of getting kth success in xth trial. Do you think this is very similar to geometric? Because if you put k equals to 1, then this is simply probability of getting first success in the xth trial, right? And you will see the mean and variance of negative binomial type 1 is similar to geometric when you replace k equals to 1. Okay, so now let's understand this from a number line. Let's say this is first trial, this is x minus 1 trials, and this is xth trial. So you're going to have kth success in xth trial. It means that you must have got k minus 1 success, right? So k minus 1 success in x minus 1 trials. Okay, so we can say that, and there could be any combination of k minus 1 success. Like first success could be on the first trial, second success could be on the second trial, third success on the third trial, and it could be different as well, like first success on the maybe third trial, okay, second success on the fifth trial. There could be some failures in between, so it doesn't matter. There could be any combination. So we could choose from out of, x minus 1 trials, we could choose k minus 1 success, p to the power k minus 1 and q to the power x minus k. And in the xth trial, it is for sure that you're going to have kth success. So this is probability p. And this is the PDF of negative binomial type 1. So the probability or the PDF is x minus 1. You can choose k minus 1 success, p to the power k minus 1, q to the power x minus k, and in the last trial you're going to have success. Okay, so now what is the range of x? Now what is the minimum number of trials that you need to have k success? K trials, right? And then you can increase this by 1, 2, up to infinity. You can have k success in kth success in k trials, k success in k plus 1 trials, k success in k plus 2 trials, and so on. Okay, now let's look at the mean and variance. So mean is k over p. Now if you put k equals to 1, you'll get 1 over p, which is the mean of geometric. And variance is kq by p square. Again, if k equals to 1, this is q over p square, which is the variance of geometric. All right, so essentially this is geometric. Now I'm not going to derive mean and variance because this is geometric. Okay, this is derived from the geometric. Now let's look at one example. If the probability that a person will believe a rumor about a scandal in politics is 0.8, what is the probability that ninth person to hear the rumor will be the fourth person to believe it. So this is the question. Let me repeat this again because this is a bit confusing. What is the probability that the ninth person to hear the rumor will be the fourth person to believe it? So this is same as saying probability of getting fourth success in ninth trial. So here probability of success is 0.8, x is 9, and k is 4. All right, so now probability of getting fourth success, remember x is the number of trials in negative binomial type 1. So probability of getting fourth success in ninth trial is 9 minus 1 c 4 minus 1. This is choosing this much success from this many trials. P, which is 0.8 to the power 4 minus 1, 0.2 to the power 9 minus 4, right, times P, which is 0.8. So now this is 8c3, 0.8 to the power 4 times 0.2 to the power 5, which is 0.00734. All right, so this is how you can solve the problem of negative binomial type 1. Now let's move on to type 2. Negative binomial type 2. Notation is x follows nb2 k comma p, where x is different. X is the number of failures before kth success. In type 1 it was the number of trials on kth success. Now this time this is the number of failures, so please do not get confused. K is of course the kth success and P is the probability of getting kth success. Now let me ask, what is the number of trials this time? Number of trials. So you have x number of failures and k success. So the sum of this is the number of trials, right? Now you can frame type 2 same as type 1. How? Let's see. You are going to have kth success in x plus kth trial, right? So now this is same as type 1. So you can say the probability of x equals to x, this is same as choosing k minus 1 success from x plus k minus 1 trials, right? So this is p to the power k minus 1, q to the power x minus k. All right, I hope you're getting, you're not confused. Okay, so this is only x, and in the x plus kth trial you are going to have success, so this is simply p. Okay, and please remember this is the number of failures. So what is the range of x now? You can have 0 failures, 1 failure, 2 failure, and so on up to infinity to achieve kth success, k success. Okay, you can have no failures, until you achieve k success, or you can have 1 failure, 2 failures, many failures. Okay, so now let's look at the mean. And mean is slightly different this time because x is different. X is not same as the geometric, so mean is kq by p and variance is kq by p square. Okay, so this is all about negative binomial type 1 and type 2. Now let's look at hypergeometric. Hypergeometric. Let's understand this from an example. Suppose there are 58 people applying for a job and only 30 have particular qualification. Okay. If 5 of the group selected are randomly selected for a survey about the job application procedure, what is the probability that none of the group selected have the qualification? So this is the question. Again, let me repeat the question. There are 58 people applying for a job, only 30 have a particular qualification, and if 5 of the group are randomly selected for a survey, what is the probability that none of the group selected have the qualification? So let X denote the number of applicants from the group of 5 that have the qualification, So we have to choose 5 people out of 58. Okay, in such a way that none of them have qualification. So we have to choose 0 from 30 and the remaining is 28. So 5 we should choose. Okay, so this is the probability that none of them have qualification. If you calculate this, you'll get 0.0214, and this is hypergeometric. Okay, so now you can put a variable here. This is m, this is k, n, and x, and you can write the PDF or the probability. This is simply choosing n out of m, x out of k times m minus k, and this is n minus x. So this is the PDF of hypergeometric. Now what is the range of x? So you can have 0 preferred candidate, 1 preferred candidate, 2 preferred candidate. What is the maximum value of x? Now you can observe from this example that here you have 30 preferred candidate, right, out of which you are going to select only 5. So there is a restriction that you can only select 5. So the maximum you can have is 5. Now what if I say that the preferred candidates are only 5 people and you need to select 30? So what is the maximum value of x in this case? This is again 5, right, because you only have 5 preferred candidates and you have to choose from the preferred. So you're going to have 5 people. Okay, so here we can say that the maximum value of x is simply minimum of k comma n. Okay, this is k, this is n. So the maximum value of x is minimum of k comma n. All right, now what is the mean and variance of hypergeometric? So mean is n times k divided by m, and variance is nk times m minus k times m minus n whole divided by m square m minus 1. This is slightly longer and we don't need to do the proof. You can simply remember this and apply in the question. All right, so this is all about hypergeometric and negative binomial. Now let's stop here and I'll see you in the next video. Thank you so much for watching.